So we have the shell method, and the shell method is used, alongside with the disk and washer method. But sometimes the shell method, sometimes it's better, and it all has to do with the way the equations go. It all has to do with whether you're able to integrate it or not. I'm just trying to make it look 3D for you guys. And but the main difference between the shell method is, so if you're rotating about the x-axis and you're using the disk method, you're going to do that in terms of x. If you're rotating around the x-axis with the shell method, you're actually going to do that in terms of y. And the other advantage to the shell method is because you're doing these shells, which are basically a hollow cylinder. The ones that we had to use the washer method for on the last lesson, it would actually be easier using the shell method. So that's just, a little bit of an advantage here. So the hollow cylinder, what is the volume of a hollow cylinder? It's, of course, the volume of the outside, or the volume of the cylinder. So we call this a shell. Just like the other things we call discs and washers, these are called shells. So the volume of the shell is going to equal the volume of the cylinder minus the volume of the hole. And I'm a little bit off the page. Volume of the cylinder, volume of the hole. Obviously. So basically, these shells, there would be, there's a shell here, there's another shell around it on the outside, and then another one. And eventually the thickness of the shells approaches 0. And once that happens, then you have the actual volume. Now we're at the point where we don't need to go through all those steps or prove all of that. We just need to do the math. So basically, we're going to be subtracting two volumes here, because the hole is also cylinder shaped. So this is going to be a cylinder, and we're going to subtract a cylinder and be left with this shell. And it's all going to come together, and we're going to have ourselves a nice formula. I'm going to jump right ahead to that formula. Now keep in mind, because this is rotating about the x-axis, but we are going to be doing this one in terms of y. So if you see shells like this rotated about the x-axis, it's actually in terms of y. And I'll write out the formula both ways for you. So this one is delta V is equal to 2 pi P of y, H of y, dy. So what do they represent? P of y represents the average radius. H of y represents the height. And then, of course, if we go ahead and we do the integration for this, if we integrate both sides, we're going to have volume equals 2 pi from C to D of P of y, H of y, and dy. So this is when it's rotated about the x-axis. And if we rotate it about the y-axis, from A to B of P of x, H of x, dx. Okay. So this one's a little bit weird. When you're rotating around the x-axis, we're doing that in terms of y. When we rotate around the y-axis, we do that in terms of x. So it's opposite. So your advantage here is depending on if a function can be inverse to be written in terms of the other variable. And typically the ones that we have here are going to be set up that they are going to be easier done in this method. Okay, so let's start. We have our two formulas, and let's see how that goes. I'm going to draw you a little picture because this is what we're going to rotate. So this function from 0 to 1 is y equals x minus x cubed. Okay? So we are rotating this about the, I know you're thinking this way, about the x-axis, but we're actually going to rotate it about the y-axis. It's going to make like a half a donut, I guess. I don't know. Yeah, something like that. Okay, so when we go to set this up, we have this formula. Volume equals 2 pi from C to D of P of x. Oh, because we're rotating around the y-axis, we're doing this in terms of x. P of x, h of x, dx. Oops, this should be a and b. There we go. Now it's a and b. Kind of. Okay. So, anyhow, we're clearly integrating from 0 to 1. So we can at least do that. We're going from here to here. And what that is that means that's where the radius is. So because let me grab a different color. Your shells, if we pick like right there, let's say, it's going to create a cylinder like this. Are you seeing? Hopefully you're seeing it. Anyhow, so the radius is going to be changing because as this moves out, the radius of this cylinder is going to change. So that's why we're going from 0 to 1. So let's do P of x. P of x is the radius. Well, the radius is just going to be x, right? Because the radius is just going to move outward. Right here it would be a really small cylinder. Out here it would be a really large cylinder. So that's simply just x. What is the height of the cylinder? Well, the height of the cylinder is going to be represented by this curve, and that's this. So the height of the cylinder would be x minus x cubed dx. And typically when you do this, one of these is going to be just a plain x or just a plain y, which is kind of nice. You're always going to have that. All right, just like before, now that we have that, the rest of this is easy. You guys are good at this. So v equals 2 pi from 0 to 1 of x squared minus x to the 4th dx. Let's integrate this. This will be, if we increase that to 3, 1/3 x cubed minus 1/5 x to the 5th. From 0 to 1. And let's do the math here. When we plug in 1, we get 2 pi 1/3 minus 1/5. And then we plug in 0. It's just 0 minus 0, so minus 0. I'm not even going to write it down. 2 pi 1/3 minus 1/5. 1/3 minus 1/5 is actually going to be 2/15 times 2 pi. This is going to work out to be 4 pi over 15. And that is the volume if we were to rotate that around the y-axis. If you draw out these figures, just do a little spinny arrow to show which way you're rotating it, and see if you could draw out the figure. I know that, like, you guys, not everybody's an artist, I get it, so you know, do the best you can. Alright, so we're just going to try a few easy ones for homework, not too crazy. These are both going to be rotated around the y-axis, so you'll do these in terms of x. So try these out. This are going to be page 437, just numbers 1 and 3. Okay. Let me know if you have trouble.